Section 7.3 is on complex rational expressions. Complex rational expressions it's really just a fancy name for fractions inside of fractions. To simplify these, we need to multiply each term by the LCD of all of the fractions. And this is not by what it needs to get the LCD. So in the previous section, when we were adding, we found an LCD, and we had to multiply by what you need to get the LCD. Here, we're just going to be multiplying by the LCD itself, technically over 1. And then our second step is to simplify. Then we need to factor and simplify more if possible. So, like I said, this is kind of similar to section 7.2, where we're multiplying by what we need to get the LCD, but now we're multiplying by the LCD itself. Our process for getting the LCD is the same. So we're going to get more practice in finding the LCD. And here are some examples of the LCDs. Again, it's the LCD of all of the fractions. So let's look at this third one here. The LCD with 4, 6, and 3 is 12. For x's, this one has 3 x's, this one has 2 x's, this one has 1 x, this one doesn't have any x's. It's the greatest number of times you see it in any one denominator, so it's going to be 3. For y's, this one has 2 y's, this one has 5 y's, this one has 4 y's, this one doesn't have any y's, so it's the greatest number of times you see it, which is 5. So definitely take a look at those. Okay, so for number 1, we're trying to simplify this complex rational expression. So I need to get my LCD. And I don't have any coefficients in front of my variables on the denominators. I'm only looking at the denominators. With the x's, this one has 1x, this one has x squared or 2x's, this one has 2x's, this one has 1x. So I need 2x's because it's the greatest number of times you see it in any one individual denominator. For y's, this one has 2, this one has 1, this one has 1, this one has 3. So I need 3 y's. Okay, then I want to multiply each fraction by this LCD. And it's over 1. So I'm not multiplying by what I need to get the LCD. I'm multiplying by the LCD itself. Over 1. Okay, so then, and I'm technically able to do this because I'm multiplying the top of this main fraction by this and the bottom. So that's technically legal to do. Okay, so I need to simplify. And I'm going to simplify each fraction. Now, after I simplify, all of my fractions should go away except for the main fraction bar. So x is going to cancel out with one of those, y is going to cancel out with 2 of those, leaving 1. So that's going to be 3xy. Both x squareds go away, a y is going to go, and that's going to leave y squared. So that's plus 2y squared. With the bottom one, x squared is going to cancel out, and y is going to cancel out with one of those, leaving y squared. And in the bottom right fraction, x is going to cancel out with one of those, and y cubed is going to cancel out. So that's going to be plus 2x. Okay, so then we should try to simplify this if possible. With the top, I can factor out a y. The bottom, I can't factor anything really. So that would be our answer.